All right, let's jump right in. We've all seen AI get crazy good at spitting out little bits of code, right? But what would it take for an AI to truly understand software? I mean, really get it. To not just write code, but to think like a seasoned developer who's wrestling with a massive, messy project. Well, that's the big question we're tackling today.
Because here's the thing. As amazing as today's coding assistants are, there's still this huge gap when you throw them into the deep end of a real-world software project. They just get lost. When they have to deal with tons of different files, long, tangled chains of logic, the kinds of problems that require a deep, intuitive feel for the code. So what's missing?
And this right here is the key. See, most AI models learn from these perfect, finished textbooks of code. Billions of lines of it, all static and pristine. But you and I know that's not how software is actually built, is it? Real software is messy. It grows. It evolves. It's all about the commits, the bug fixes, the late-night refactoring. The AI was basically reading the last page of the book without knowing any of the plot. It was missing the why.
To fix that, you need a totally new way of thinking. And that's where IQuest-Coder comes in. It's a brand new family of models, and it was designed from the ground up to close that gap by learning the process, not just the pretty, finished product.
So this isn't just another incremental update. It's a pretty fundamental shift in approach. The whole goal here is to crack that tough nut of long-horizon reasoning. That's the ability to plan and carry out complex tasks that span an entire code base. To pull this off, IQuest-Coder uses this really structured multi-phase training that's all about packing in more reasoning power.
And you can tell they went all in on this. I mean, it flat out achieves state-of-the-art performance. And we'll get to the receipts on that in a minute. It's also not just one model. It's a whole family, different sizes for whatever you need. And maybe the most important part? It's balanced. It's a rock star at code, sure, but it doesn't forget how to handle regular language and math, making it a seriously versatile tool.
So how'd they do it? What's the secret sauce that lets this thing actually think more like a developer? Well, it all boils down to this really clever training idea they call Codeflow. This analogy just nails it. A normal model gets the finished, published textbook. It's clean. It's perfect. But with Codeflow, IQuest-Coder gets to see the whole messy, brilliant process. It gets the author's early drafts, the notes scribbled in the margins, all the crossed-out paragraphs, everything. It learns from the journey of development, not just the destination.
So here's a look at that Codeflow pipeline, straight from the technical paper. You can see how it learns in these stages. It's not just looking at code, it's analyzing Git commits, the whole history. And it's also learning from what they call agentic trajectories, which is a fancy way of saying it watches other AIs try to solve problems, and it learns from their mistakes and their breakthroughs.
Let's break down that journey. It happens in 4 phases. First, there's pre-training, which is all about building that solid foundation on just tons and tons of code. Then comes the really critical part, mid-training. This is where they inject that deep reasoning, those agent-like behaviors. This is where it learns to think. And finally, in post-training, things get really interesting because the model actually splits into 2 specialized versions.
So you end up with 2 distinct flavors. You've got the instruct model, which is like the ultimate co-pilot, right? A super-powered partner for your day-to-day coding. But then you have the thinking model, and that's a whole different beast. It's trained to be an autonomous pro, built from the ground up for those super complex, long-term problems that need a mind of their own.
Okay, the theory sounds amazing, but talk is cheap, right? Does it actually work? Let's get to the fun part and look at the benchmarks. This is where the rubber meets the road. Now we're going to focus on a benchmark called SWE Bench. And this is not some simple coding puzzle. It takes real bug reports, real issues from open source projects on GitHub, and tells the AI, go fix it. It's incredibly hard. And until now, the very best, top-tier models were maxing out right around 77% solve.
And then IQuest-Coder enters the chat. On that same super tough benchmark, it didn't just inch ahead. No way. It just blasted past the competition, setting a brand new state-of-the-art. That is a huge leap forward.
Just let that number sink in for a second. 81.4. That's the percentage of real-world, messy, frustrating software bugs that this model could just fix on its own. It's proof positive that teaching an AI the flow of development pays off in a massive way when it comes to solving actual problems.
But this might be the most exciting discovery of all. The researchers found that the thinking model started to develop something they call autonomous error recovery. What that means is it doesn't just write code blindly. It can tell when its own plan isn't working, debug its own mistakes, and try a different approach. That is a game changer and a huge step toward real autonomy.
So let's pull back for a second. We have a model that gets the flow of development, smashes performance records, and can even fix its own screw-ups. What does a breakthrough like this really mean for how we're all going to build software in the future?
At the end of the day, here's the big takeaway. We're officially moving past the era of just simple coding assistants. This is a major step toward truly autonomous software agents. I mean, this is the foundational tech for an AI you could literally assign to a project, tell it to maintain the code, build out new features, and manage the whole thing with just a little bit of human guidance.
And that leaves us with a pretty mind-blowing question, doesn't it? The debate is no longer if an AI can write code. We're so past that. The new frontier, the next big thing, is an AI that can reason, debug, and evolve software all by itself. So the real question we have to ask ourselves is, when we have something that powerful in our hands, what are we going to build?